All right, in 7.3 part B, we're going to look at adding vectors and scalar multiplication. All right, so let's just read along here. The two basic vector operations are scalar multiplication and vector addition. In operations with vectors, numbers are usually referred to as scalars. So it's just like a constant or a regular number, but it's called a scalar. Geometrically, the product of a vector v and a scalar k is the vector that is the absolute value of k times as long as the vector v. All right, so before we do the second thing here, let's talk about just multiplying, scalar multiplication. So I'm going to show you this here, scalar multiplication. All right, so let's just say I have a vector that is, the component form is 1, 3, okay? So that would mean it starts here and it ends here, right? Now, if I multiply it by a scalar of k2, that means I'm multiplying both parts of the component form by 2. So it's just 2, 6. And what does that do? Well, that just extends this, like does it 2 times as long. 5, 6. So it's going to be up here. So it doubles the length of the vector. So it multiplies it by 2. That's what scalar multiplication does. So you literally multiply the x by the 2 and the y by the 2, or whatever the scalar value is. Now, what about addition? All right, addition is a little different, but it's not difficult. All right, let's say I have two vectors. Let's say u is 2, 1, and v is negative 2, 2. So at 2, 1 is right here. Negative 2, 2 is right here. Okay, so this is saying I can add u to v, because here's u, right? Here's v. If I add u to v, that ends me right about here. Or if I added v to u, that ends me right about here. Okay, so either way, I'm landing at this point at 0, 3. So how would that happen? Well, it happens because when you add them, you're adding the x component and the y component. So when I add them, I have 2 minus 2 gives me a 0, and 1 plus 2 gives me 3. So I literally add the x and the y components, and that's all it is. Now, here it is in weird notation, so just hang in there. Definitions of vector addition and scalar multiplication. Let u be the component of u1, u2, and v, v1, v2. Be vectors, and let k be the scalar. So k, remember, is just a number. Then the sum of the two is, notice what's happening here, u1 plus v1, so it's taking the x components and adding those together, the y components and adding them together. So it's literally just adding two vectors. You end up with a vector, it's the sum of the x's, the sum of the y's. All right, let's try one here. Let's say that u is 2, 1, and v is negative 2, 2. This is what we did on the graph, right? So when we do u plus v, what am I actually doing? I'm 2 plus the negative 2, 1 plus 2 gives me 0 and 3. There's the sum of my two vectors. Now the next part, and the scalar multiple of k times u, notice this is what it looks like, really just multiply each part by the scalar number. Okay, let's try this one. Let's say that vector u is 1, 3, and they want us to find 2 times u. Well, it's 2 times 1, 3 gives me 2, 6. Multiply each term by that 2, or the scalar. Okay? What about this one? A negative of vector v, v1, v2, is just negative 1 times the vector. All right, it just changes those values. So for example's sake, let's say our vector is 4, negative 5. If I want negative v, I'm basically multiplying each term by negative, so it makes it negative 4, positive 5. Now it's important to realize what's happening though graphically when you do this. So think about this for a moment. Vector v was a 1, 2, 3, 4, down here, right? There's v. And then what did the negative vector do? Well, it went 1, 2, 3, 4, negative 4. It went just the opposite direction. Okay? It changes the direction of it. So this is negative v, this is positive v. So it's good to understand what's happening visually as well. And then lastly, we have the difference of two vectors. U minus v is equivalent to u plus the negative of v, okay, just like any difference would be. And so notice what's happening here. We subtract the first terms, the x terms, subtract the y terms. So let's try one of these. Let's say vector u is 3, 4. Vector v is negative 2, 5. All right, if I want u minus v, that means u plus the negative of v. So here's what I would do. I would take u, 3, 4, plus the negative v, so I'm changing my signs, 2, negative 5. And that lands me at 5, negative 1. All right? And that's it. That's all there is to scalar multiplication and addition. It's really not a difficult lesson. It's a very short video. Tomorrow's video is going to be a lot longer, so take it while you got it. All right, we'll see you in class.